A warm greetings from Rohini College of Engineering and Technology. I am Professor Radhika from Chemistry Department. In this video lecture series, we discuss about nuclear energy. After the completion of this course, students can explain the importance and need of nuclear energy. Let us see what is nuclear energy. Nuclear energy is nothing but it is a form of energy which is released from nucleus. Nucleus contain atoms which are made up of protons and neutrons. The source of energy can be produced in two ways. One is fission and another one is fusion. Fission means the splitting of nuclei into several parts. Fusion means the nuclei fuse together. At the time, the enormous amount of heat energy is released. That energy is called as a nuclear energy. That is, the amount of energy released during the fission and fusion reaction is called as a nuclear energy. Let us see nuclear fission. Nuclear fission means the conversion of a bigger nuclei into smaller nuclei. That is the conversion of splitting of heavier nuclei into two or more smaller nuclei with the release of large amount of energy is called as a nuclear fission. Here let us take the uranium-235. It is a very big heavy nuclei. When it is bombarded with one slow moving neutron, it forms one unstable compound, then immediately it undergo fission. It produces barium krypton with the liberation of 3 neutron plus enormous amount of energy. This energy is called as a nuclear energy. So this picture also describes the nuclear fission reaction. The large amount of energy released during the fission reaction is known as the nuclear energy. So in fission reaction, the sum of the masses of products is less than the reactant's total mass. Therefore, the loss in mass is converted into energy by Einstein equation. E is equal to mc squared. We know that E means energy, m means mass, loss in mass, c is equal to velocity of light. Let us see the characteristics of a nuclear fission reaction. So, in nuclear fission reaction, the heavier nucleus is split up into two or more smaller nuclei. At the time, the neutrons are released, enormous amount of energy also released. During the fission reaction, the fission products also radioactive in nature. They are also giving beta and gamma radiations. These fission reactions are self-propagating. The neutrons which are emitted in the single nuclear fission reaction can propagate another nuclear fission reaction. So here the emitted neutrons once again hit the bigger nuclei and also producing the nuclear fission reaction continuously. Therefore, that reaction is called as a nuclear chain reaction. In nuclear fission reactions, which are controlled by absorbing the excess number of neutrons. The number of neutrons which are released from a single fission is called as a multiplication factor. If the multiplication factor is less than 1, there is no chain reaction. Let us see nuclear fusion reaction. So nuclear fusion is nothing but the process in which two or more smaller nuclei combine to give a heavier nuclei is called as a nuclear fusion. So this diagram indicates the nuclear fusion reaction. The combination of protium or deuterium or deuterium isotopes combines with each other to form a bigger nuclei, helium. Let us see the difference between nuclear fission and fusion reaction. So we discussed the characteristics of nuclear fission reaction as well as the fusion reaction. Now we discuss about the difference between nuclear fission and fusion. So nuclear fission is nothing but the splitting of heavier nuclei into smaller nuclei. during the fission reaction, it emits neutrons. This kinds of nuclear fission reaction takes place at the ordinary temperature. The fission reactions can be controlled by absorbing the excess number of neutrons. It also a continuous chain process. Here, the fission products, the smaller nuclear products are radioactive in nature, which are emitting the beta and gamma radiations. The energy released is less when compared to nuclear fusion reaction. Let us see nuclear fusion. So nuclear fusion is nothing but the smaller nuclei combined to form a heavy nucleus. During the nuclear fusion reaction, it emits positron. The nuclear fusion reaction takes place very high temperature. The best example is inside the sun, the nuclear fusion reactions are going on. The nuclear fusion reactions cannot be controlled. It's not a chain process. Similarly, the fusion products do not form any radioactive products. It does not emit any radioactive radiations. Very high amount of energy is released during the nuclear fusion reaction than that of the nuclear fission reaction. See, this is a nuclear chain reaction. Already I told you that one neutron is enough to hit one uranium-235. At the time, it liberates 3 neutrons. That 3 neutrons, once again, each neutron among the 3, each neutron once again hit another one uranium-235. It also produces fission products with the liberation of 3 neutrons plus energy. Similarly, each neutron emitted in a single fission reaction can also propagate the continuous chain reaction. Therefore, this reaction is called as a nuclear chain reaction. Let us see the uses of nuclear energy. We know that the nuclear energy is used to generate electricity. It is also used in medicine, in the treatment of cancer disease. Similarly, it is used in the improvement of agricultural and industrial activities. It is used in scientific and research field. It also making consumer products, industrial applications, and also it is mainly used in space activity also. So in this video we discussed that what is meant by nuclear energy, what is nuclear fission, what is nuclear fusion, what are the characteristics of fission and fusion, what are the difference between them and their applications. Thank you. Thank you for listening.